address the MapReduce framework, we talked about a scenario, the story which we had, an example which we took with the playing cards. Now let's try to take another example which is commonly taken, and we will dissect that piece by piece to really look into the code, how exactly that is done, what are the components, how it is brought in together. So for that, I have a different example which I have taken. This is a very common example, which is called as a word count example. In a big data world, this is considered to be the hello world program. In other tech programming languages, we start with Java or any kind of technology programming languages, we start with a hello world. But writing a hello world program in the big data world would not make sense because it won't be big data, just writing 2 words. So the equivalent situation in this world is considered to be a word count problem. Word count meaning like you have a set of sentences and you are really trying to identify how many times a particular word has appeared in the whole set of data. So that's what we will try to do. So when we had the example of the playing card, think about that. The deck of the card was the input of data. In this situation, this particular information, a small file called file.txt, let's say it's a 200 MB file. We have taken a simple example. In real world big data, you'll have terabytes of data. But keeping it simple, file.txt is having 200 MB. The part which I was saying, parallel execution and dividing the workload among different people. In the playing deck example, we really brought friends to do that. Similarly, big data always does that. Hadoop MapReduce always does that, breaking the data into small parts. And there are set rules which define that. There are settings which define how much particular block each data should be broken down. So typically that is considered to be a 64 MB or 128 MB set of data, sometimes 256 as well. So that setting is mentioned. Based on this setting, the data, the 200 MB file, would be broken down into different parts. In this situation, it's broken down into 4 parts, 64 MB 3 PPA parts, and then 8 MB final part, which is left over. So that's how we have got 4 different blocks, which we call as. So these 4 blocks, which we have got, would be the input file and given to different mappers. So the mappers are the ones, the 4 different mappers are generated because there are 4 parts. It will have 4 mappers, and each part is given to the mapper. Now this is called as the input split. So we have taken the data, the input data, and split it into 4 parts. So each mapper got data from an input split, but there is another thing in between. A mapper can only read data, it only understands the language of key value pairs. It needs the data into key value pairs. What we have been provided is a bunch of text. So that's why there is something called in between a record reader, a translator which really translates the input split and converts it into mapper. That's what we are doing into the mapper format. So we have brought a mapper which is going to have this data input split translated for us and ready for the mappers to read in the language which it understands. So the first part, let's take a deeper look at the first part. So this 200 MB file, it was broken down into 4 parts, and this first part, the 64 MB part, it was given to one of these mappers. So it got these words, and what the mapper is going to do is going to take each of these words and just tag it together and saying how many times it was coming. It won't even do any counting. At this point of time, it's just going to group it together. This is the way it would, each of these mappers are going to keep on producing the output. And next step, which we talked about, was the shuffle and sorting phase. This is where it will try to take all of these different keys, which we have, twinkle and little, star, all of those words together and given it to the reducers. And the reducers are the ones who are going to take these keys and really do the counting and produce the final output. And this would be the kind of file which would look like. It may not be the exact output at this point of time, but it gives a sense. So what I wanted to have a pictorial view before we go into the code. And because we'll be going deeper and understanding these parts within the flow helps us to understand the code much better. So that's why I want this high level view in eyes of people before they really go into the code. Let's talk about few of the components or terminology. So we got the input data and we split that into parts. So what we call them as is input split. An input split is a logical entity. It's not something physical. It's a logical entity. What really physical equivalent of that is the HDFS block. So the data in Hadoop or big data, when it's kept in HDFS, it's broken into these blocks. And that's why, depending on the setting, we had a 200 MB file. It was broken into 4 blocks. So that's what the terminology between the input split and HDFS block is to be kept in mind before we go forward. So what we have to really write as a developer, you have to write the code for the mapper. We have to write the code for the driver and the code for the reducer. What the driver is doing, the one who is trying to piece it all together. So we have a mapper, we have a reducer code, and the driver is something which is going to call it all together. So this code, which I'm just flashing it here, I won't be really going at this point of time. I'm just going to flash through all these codes, and then we'll go dissect each one of them together. So there is a reducer code, as I said, and then there is a final driver code which has multiple components to it. So we'll quickly, briefly just flash through it, and here is what we are going to do. So we saw this pictorial view. Again, the overall view which we had the mapper part of it, it had the shuffling and sort, and the reducer part of it. Now, let's try to do the code and the pictorial view side by side, what we'll compare. So now I'm really focusing only on the mapper part. So I've zoomed in my pictorial view into the mapper side of the code, and you see this mapper over here. So our focus should be completely on the mapper, and we'll talk about the code in alignment with that. So let's talk the code line by line. So first chunk of these lines, or this block, this code, MapReduce is written in Java. MapReduce programs are mostly written in Java. That's why this is an example taken in Java. We have a series of import statements. What these import statements are doing for us, we are not writing everything from scratch. We are taking a lot of these libraries and implementations which are done already by the MapReduce Apache Foundation, and we are incorporating that. So that's the first set of series of import statements. What I want you to focus on is the word mapper. This is the class which we are writing. We are writing a public class, but we are not writing it from scratch. We are extending the base mapper class, which is provided by these libraries and in front of us. After that, we are providing 4 different parameters or arguments. What are these? These are the key arguments, and here is where we start relating it to the diagram. 4 pieces of information, and the first 2 pieces are the input to the mapper only. They're focusing on the input to the mapper. So what is the mapper getting? So it is the key value pair for the mapper. So the mapper is getting the data from the record reader. So it's getting the sentence, but it also is getting the byte entry. It needs, as I said, it needs a key value pair. So for here, this key and value, input key, input value, those are the first 2 things. For this one, it is a numerical value because we are just taking a byte offset code, and the text is the value. What we are getting a text format of data. So that's why we write text. So you need to understand the first 2 parts are coming right from the mapper's input. The last 2 parts of arguments are really the output of the mapper. The output, what is the mapper's output? The mapper is providing us twinkle and 1 and 1. So when you look at this pair, it is text and numerical, which is int writable. So that's what the output part of the mapper is doing. So that's how we always create this component. This is the input-output part of the mapper, which is being defined. Looking into this part of the code, and this is where the magic happens. This is what the individual developer needs to define and say what his program is going to do. In this situation, we are doing a word count problem. So the word count problem, how is word count defined? A word is defined by identifying spaces, and we're just counting or just putting it, grouping all this, collecting all these different words. So twinkle is the first word, and we're just doing a split on the space. So we have a sentence, and we are identifying the spaces, and we're just looping through it, and we're just collecting all of these different possible words split by space. So this is things which you need to go line by line into it. That's not the primary intent. What really people need to understand, this will be different. It is depending on what program you are writing, what logic you are writing, what problem we are solving. From that perspective, it will be really written. In this particular case, it is written to split by space and keep looping through it and collect all these different words. The structure which the mapper code is having, let's go to the reducer side of the code. And now that we have got somewhat of a structure defined how we are addressing it, similar pattern has been followed at the reducer side as well. We have a series of imports which help us enable to borrow all those libraries which are already created by the Apache implementation. And then what we are doing, we are defining a class, whatever name we want to define. Here I've defined as word reducer, and we are extending the base of the reducer. So we're not writing it from scratch again, we are extending it. This also has 4 different arguments defined. The first 2 again, same pattern. It is the input key value, and the next 2 last 2 are the output key value. But these are inputs and output for the reducer. So what is the reducer's input? The output, whatever output the mapper gave, is the input for the reducer. So if we go back to the previous one, whatever was written in the last 2 in the mapper situation, it was text and int writable, text and int writable. The same has been brought in over here because that becomes the input for the reducer. So that's the reducer's input. And what is the output of the reducer or the final output? So we as a programmer need to understand, like, what are we expecting out of this program? I'm expecting a word count program, and that's why it will be a word and there will be numericals behind it. So text and int writable again, because it's text and some numerical value. I mean, it could be long if there's large numbers, but in this case, it's going to be simple numerical count, which int writable should be good enough. So that's how we have defined this part of the code. In the logic of the code, again, this is going to be depending on each problem by problem. In this case, word count reducer problem, what we are really doing, taking these inputs, defining a count, initiating an account is equal to 0, and then looping through all of those words. And if it is coming in again, we are incrementing that count and just keep doing it till we finish all the words. And that's how we are producing this output. So primary intent of this flow is to really understand, dissect these pieces of what a typical MapReduce program has, not specifically the logic and the code at this point of time. Third piece of code which has to be written is the driver code. The driver is the one which is going to bring the mapper's code, the reducer's code, and mix it up all together and make it magic for us. So the driver code is let's try to do what the driver code is trying to do as well. At a high level, the driver code is trying to do 5 different things. Setting up the stage for all of those different pieces of information to be brought in and successfully done. First piece is defining a job conf, which is an instance of this class, which we are instantiating that, so which is defined over here. This is pretty much similar in most of the cases it would be. Then we are defining the second part. We are defining the input and output format and the locations. So the actual arguments, if you think where my data is going to sit as the input and where my data is going to be as part of the output. That's what we are putting in this situation. Here is the one where we are tying up all these pieces together. The word mapper, remember what I was showing in the word mapper program, which I could have written out anything. They could have written big data trunk mapper, big data trunk reducer, anything which I could have written. But those names have to be exactly same here. This is where the pieces are being tied together. There are last 2 pieces over here which we are going to define is to specify the mapper's output, how the mapper is going to result the output. Again, what we are looking in the parameters, and we are also specifying at the driver's code level, the text iterable, and again the final reducer's output format as well, which is text and iterable as well. At a high level, you can think of the driver code to be very similar, having these components. The actual code may be very different, but at a high level, these components will definitely be there. Talked about the combiner and other components, those components, if you bring in pieces together, those other codes have to be also written down. So as many pieces of components which we define in your MapReduce program, those have to be brought in and they have to be tied in together using this driver program. So this was a quick dissection of that particular simple program and just connecting it together with the example which we looked in and the code fed. So that brings us to questions.